Welcome everyone to this webinar. It's a pleasure to have so many guests joining us today. My name is Catherine Lining. I'm a policy fellow at Motu. I manage our program on shaping New Zealand's low emission future. For those of you who are not familiar with Motu, we are a non-profit independent research organization based in Wellington, New Zealand. We hold weekly seminars that give our researchers and visitors a chance to present work in progress and make it available for critical discussion and review. And today we are absolutely delighted to be welcoming Jeremy Webb to give a presentation today. I first encountered Jeremy when he was starting his PhD work in London. He's originally from Christchurch, and I'll give him an opportunity to present himself in more detail, to introduce himself. So it's very exciting to have him back now toward the end of his work and to get to hear how he's progressed. He has agreed that we can make this recording available publicly on Motu's website, and he will also have a PDF of his slides available. Please just keep in mind that he'll be planning to publish a lot of this work and attribute any information you take from him to him, and that will be great. For those of you joining us in New Zealand, I'm also serving on the Climate Change Commission, but today I'm participating in this in my Motu capacity and will not be representing the views of the Commission. I do have some of my Commission colleagues here as well, and welcome to the call, and we'll look forward to their input during the Q&A. We're going to focus a lot of this webinar on Jeremy's presentation. That will probably take 45 to 50 minutes or something like that. And then just to kick off the conversation, I've invited two people to give a brief response. The first is Jonathan Boston of Victoria University, and the second is Christina Hood, who's working here as an expert independent consultant and was recently directing the climate change program at IEA in Paris. So, and after that, we will open it up for Q&A, and I'll stop the recording at the Q&A portion. So on that note, I will just remind everyone that we are being recorded during this portion, and for that reason, we're going to ask you to hold your questions on Jeremy's presentation until we get to the end. Just to allow him to cover the extensive amount of material, and then we'll have some good Q&A at the end of that. So I will stop my screen share. And Jeremy, if you want to take it over from here, that would be great.
Excellent, thank you very much. Here we go. Right. Okay, so thank you very much, Catherine, for organising this, and it was great catching up with you, and I was really stoked when you said you'd be willing to organise something like this. Thank you everyone for joining. It's a little bit, I'm a little bit blown away by the number of people and also the range of people and the quality of work you guys are doing. So it's a real privilege to be here. So yeah, my name's Jeremy Webb. I'm from University College London, although at the moment I'm sitting in Cass Bay, New Zealand. And I'm with the Department of Science, Technology, Engineering and Public Policy. And I'm also glad that a couple of my colleagues from there, who are both Kiwis, Paul Honeybone and Jenny MacArthur, have also joined us from London this morning. A bit about myself. In terms of professional experience, I started life at Environment Canterbury after I got my first couple of degrees. I was a groundwater technician there. I then got a job at Statistics New Zealand working on environmental economic accounting. After that, I then joined the United Nations Statistics Division, working on environment statistics and environmental economic accounting, developing the international statistical standards. After that, I thought, well, let's, it's all very good sitting in New York, talking about different countries and the things we should do. But I thought it was, as a UN staff member, it's really important to spend time in the places we talk about. And also I wanted to see if I could take what we did in statistics and be a bit more applied. And hence I joined the African Climate Policy Centre. As you'll see on the slide, it says I was engaged in program management. I was there ostensibly to work on data related issues. But because I was the first staff member, I had to help get it established. And by the time I left, we had around 27 staff members. I then spent a short time with the African Centre for Statistics, working on economic statistics and the system of national accounts. And then I joined the African Minerals Development Centre, leading the development of the Geology Information Program there. In terms of academic training, University of Canterbury, a Bachelor of Science and a Masters of Science in Geology. I've had a long-standing interest in why some parts of the world do better than others and why some people are better off than others. And hence I went to Massey University, did extramural studies on a postgraduate diploma on development studies. And most recently, of course, University College London. I'm a doctoral candidate there in the Department of Science, Technology, Engineering and Public Policy. In addition to these things, I'm currently also leading a solar energy subgroup under the United Nations Economic Commission for Europe, developing resource classification standards. And I'm working with some colleagues establishing what we're calling the Tiaki Institute. So yeah, extensive experience, which I think has helped a lot when it comes to my area of study. In terms of the presentation, you might be wondering what I'm going to talk about. So this is the outline here. We're going to start with the climate change problem. We're going to look at scenarios. I'm going to go through the data collection I did, the data processing, the analysis, and we're going to finish with the preconditions for effective global responses to climate change. You might be wondering why I chose the satellite image as my background for this particular slide. And the reason is because it highlights that sometimes it's really good to step back and see the big picture. So in this case, we have the New Zealand and we have the Southern Alps there. And in the Southern Alps, when we look down at the Southern Alps, we can clearly see the Alpine Fault moving from the bottom of the South Island up through to the top corner there. I spoke to the geologists that actually found the Alpine Fault when I was doing my geology studies many years ago. And they said they were finding these really large shear zones and it was really hard to work out what was going on. But of course, they didn't have the benefit of a satellite image where they could step back and see clear as day what is happening. So what I'm trying to do with regards to climate change and the global response system is take that step back and see what are the main features of that system. Okay, a bit of background. So this is a graph from the fifth assessment report of the Intergovernmental Panel on Climate Change. On the, if you can see my mouse there, over here we have those bars going from white up until kind of a nasty shade of purple, indicating that the risk is undetectable through to very high. And this includes risks to unique and threatened systems, such as in the Arctic or coral reefs, etc. There are extreme weather events as another reason for concern. There's the distribution of impacts. Not everyone is impacted equally, not all places are impacted equally. Then there's the global aggregate impacts. And this, for example, if you read the text from the fifth assessment report, could possibly include stock market impacts as well as the things we more readily associate with climate change. Then there's large-scale singular events. And this refers to what we often talk about with regards to tipping points or feedbacks, for example. Business as usual, somewhere between, well, it's changing these days, but when I first made this slide, it was around 4 degrees Celsius of global warming anticipated. If we apply the nationally determined contributions the pledges countries have made, then we get to around 3 degrees Celsius. The Paris Agreement purpose is to be well below 2 degrees Celsius of global warming. And today we're currently at around 1 degree Celsius of global warming, which means in terms of these reasons for concern, they're undetectable to moderate as we stand currently. But in the future, they could go up dramatically. Now, many of you will remember Christiana Figueres, and she's still very active around climate change issues. She was the Executive Secretary of the UNFCCC for some years. And she said, we have 3 years to safeguard our climate. This was back in 2017 in a paper in Nature. What did she mean by that? What she meant is we have to get the emissions curve down, and if we don't do it by 2020, then it gets really hard to do. I think in January, most of us would probably have said it was pretty unlikely that we were going to get it down in 2020 in some dramatic fashion, but of course things have changed, and with the COVID situation, we're certainly seeing an immediate drop in emissions. Whether that continues is an open question. With regards to with regards to stabilizing atmospheric concentrations of greenhouse gases in the atmosphere, the emissions gap report looks at progress. And it has a quote here which I'll read. As in the earlier emissions gap reports, it is important to highlight that most scenarios that are available in the literature and that limit warming to below 2 degrees or 1.5 degrees Celsius assume the use of so-called negative emissions technologies in the second half of the century. That is the active and permanent removal of carbon dioxide from the atmosphere. This is very important. The 1.5 degree report that came from the Intergovernmental Panel on Climate Change also highlights the need for greenhouse gas removals from the atmosphere. And if we were to keep temperatures down to 1.5 degrees, even in an overshoot scenario, greenhouse gas removals from the 1.5 degree report would have to start before 2050. But having said that, this is a screenshot from a Twitter post from the UNFCCC. And it says, look, we have solutions to prevent catastrophic climate change. Yes, there's the Paris Agreement, there's business and investment, there's technologies, there's affordable renewable energy, there's public support. And there's also the Drawdown project, which showed there's 100 different solutions, and they ranked the top 80 there as well. There's IPCC assessments, which include mitigation as well as adaptation and the possible options there. So when I started my study, I was looking at what are the options to address climate change. And I realized those options exist, they're peer reviewed and they're published. So the question is not what are the options? The question is who could implement these options and these solutions? Under what conditions would actors implement these things? And that's when my study took a change of focus. This is a wee plot which kind of shows in one picture the kind of my mental model when I started out of where we're at and what the issues are. So here we are, we're moving along. We have Rio, we have Kyoto, we have the Paris Agreement, and now we've got a choice. Do we keep on a trajectory of growth and increase stress on the environment, or do we take a change and move down and limit climate change to well below 2 degrees Celsius? And the idea is then to limit any calamities associated with climate change. I showed this to my former boss from the African Climate Policy Center, and he didn't like the diagram at all. And you might be able to spot what the problem is. The problem, as he highlighted, because when I asked, why didn't you like it? He goes, well, those people falling off the cliff, we don't do that together. There are some people for whom 2 degrees of global warming is already a calamity, and there are others who will not be in anywhere near as much trouble. Having said that, though, the IPCC highlights climate change as a collective action problem. Of course, the emphasis is on an action. If we don't act together, we will not be able to solve the problem. But having said that, the distribution of the problem will impact people differently. And the other thing is we're entering unprecedented climate change conditions. As you saw from those reasons for concern, if we go much higher, we start going from moderate impacts to high to very high risk of impacts. So what are my research questions? What are the preconditions for effective global responses to climate change? That's what I'm aiming to solve with my doctoral studies. Under what conditions would actors act on effective response options? So this is getting to the question of, hang on, when would we do this? There are some sub-questions here. What influence might climate change have on actors in the global response to climate change? Given that we're moving into an unprecedented set of climate conditions, how will that affect people and their responses? What are the preconditions for actors to remove greenhouse gases from the atmosphere at a scale required to limit climate change to safe levels? So this question speaks to the need for greenhouse gas removals and what it would take for people to want to do that. Then there's what are the preconditions for effective international cooperation on climate change? And this is getting to the point of collective action, but more particularly through international institutions. I'll just mention one other thing. Initially, I should also mention that when I started my study, when I realized, okay, let's move away from what are the options, I then started focusing very much on the international institutions part, this international cooperation part. And that's when I first met Catherine Lenning, for example. I was asking questions around the UNFCCC and the Paris Agreement and various scenarios around international cooperation. But I think a key distinction has to be made. International cooperation is not the global response to climate change. The global response to climate change is everything everyone does to address climate change, of which international cooperation is an important part. But the bulk, in terms of the response and how we measure it, happens at the national level and at the sub-national level. That's why we have emissions inventories measuring the greenhouse gas emissions at the state level and at the sub-national level. So when I say the global response to climate change, I'm not exclusively referring to international cooperation. I'm referring to international cooperation, and I'm referring to everything everyone else does as well. Okay, scenarios. Ramirez et al. Have shown that using appropriate methods, scenarios can produce interesting research that is both usable and rigorous. So what I'm saying is, hopefully using scenarios is justified. The question as to whether it's interesting, I'd like to hear from you afterwards. The IPCC has assessed integrated assessment models, representative concentration pathways, and shared socioeconomic pathways. These are all different forms of scenarios and models for generating scenarios. The representative concentration pathways, of course, are a curve regarding emissions and the extent to it's essentially an emissions curve, and then underneath it you work out what it would take to hit that curve of emissions, and then above that you say, well, what would that emissions curve mean for impacts on the environment, global warming, etc. It's really a means of bringing together, to communicate, to bringing together different parties studying different aspects, and to say, well, if we look at this one curve, what would it take for that, and what are the implications of that? The shared socioeconomic pathways came from a similar group of people looking at, okay, well, we haven't addressed socioeconomic variables sufficiently. What are some of the possible scenarios here? What are some of the variables and the numbers we might have? And created 5 shared socioeconomic pathways. But these things are not without their faults, and to the credit of the IPCC, they've been very clear in some of the limitations around the models and the scenarios. And that's where a lot of the material for the slide comes from. The models use economics as a basis for decision making. Well, that's great, and that's highly amenable to modeling, especially when it comes to quantitative modeling. But what about security and other decision criteria driving global responses to climate change? While we're at moderate levels of risk, maybe economic decision making is clearly a paradigm, but what happens when we get to high or very high levels of impacts? Will we still be using economics as a basis for decision making? Decisions in these models tend towards the goal of minimizing the aggregate economic costs of achieving mitigation outcomes. Okay, but it's not clear whether incentive structures for actors, including oil and gas companies or so-called petrostates, would actually result in minimizing aggregate costs. And this, of course, comes down to the issue of externalities. So on one hand, we can model within the boundary of the economy what is best overall, but at the same time, there's a whole set of incentive structures, some of which may align with that and some of which may not. The models do not structurally represent many social and political forces that can influence the way the world evolves, e.g. shocks such as the oil crisis of the 1970s. Yet these shocks can drive systemic change and affect greenhouse gas emissions. In fact, if you've read the book Black Swan, you'll see the case is made that these shocks are actually some of the most influential in terms of where we go as a society, as a group, collectively. The IPCC noted that omitting climate impacts and adaptation responses from scenarios is likely to lead to biased results for 3 main reasons, and they gave the 3 reasons. Climate impacts could influence the effectiveness of mitigation options. Adaptation responses to climate change could themselves alter emissions from human activities, either increasing or decreasing emissions, reductions required to achieve GHG concentration goals. Mitigation strategies will need to compete with adaptation strategies for scarce investment and research and development resources. assuming these occur contemporaneously. Now, these are 3 good points, but the thing I'm interested in here, and the thing I want you to focus on, is not these 3 points. It's this last one. The possibility of climate change impacts influencing ambition levels of actors and their responses does not appear to have been acknowledged as a possibility. And this is really important. If we're going from just undetectable to moderate impacts and risks to something much higher, well, maybe those will influence ambition levels. This is a question. So these are some of the questions that were in my head as I started moving down this trajectory here with regards to scenarios and what we need to get information on. So data collection, how on earth do we collect data on these things? Do we just go and ask people about it? What do you think about this, this, and this? Given that we're talking about unprecedented conditions, how do we get a representative sample of possibilities here? So I created a survey, a semi-structured survey. And in this case, the questions started with the current climate change situation. I just simply asked people, please describe the current climate change situation. Then, what is a failure scenario? So I'd ask people to say, well, please, can you give me a failure scenario? Can you describe a success scenario? And can you describe other scenarios that affect climate or the global response to climate change? The methods I used are backcasting and reverse stress testing. Backcasting comes from the environment field where we where we say, okay, this is what we're trying to achieve, and we work back from it. This regards the success scenario. Reverse stress testing methods are from finance, and they're based on looking at what happened during the financial crisis with stress testing being inadequate. They said, well, perhaps a good way to improve the scenarios we use is to start with what would failure look like and then work back from that. And so that's the failure scenario part here. The other scenarios that affect climate or the global response, why did I ask that? Well, that's because those other things that can have a big, profound impact on a system, that can have a big, profound impact on climate change. And 2, one of the deficiencies identified during the stress tests prior to the financial crisis was the lack of other scenarios being included. So what is success? I mean, I've asked for a success scenario, I've asked for a failure scenario. What is that? Well, in this case, it was fulfilling the UNFCCC objective. So if we take the United Nations Framework Convention on Climate Change objective, it's to stabilize atmospheric greenhouse gas concentrations at levels that allow ecosystems to adapt naturally, food production not to be threatened, and economic development to proceed in a sustainable manner. These are the criteria I use for success. So when I asked people for those scenarios, I said, please, can you describe a scenario where we stabilize atmospheric greenhouse gas concentrations at levels that allow ecosystems to adapt naturally, food production not to be threatened, and economic development to proceed in a sustainable manner? I use this because it's also the main framework convention for addressing climate change. And 2, it's a bit more clear in terms of what we're trying to achieve than just saying 2 degrees Celsius and using the Paris Agreement. Data processing. So I conducted 27 interviews. I collected 238,000 words of transcript, from which 176 scenarios were identified and thematically analyzed, forming a searchable sample of possible futures. So for each of the interviews, I went through and I identified these scenarios, and then I coded them thematically, so then they could be searched. And so for any given issue of interest, I could type in a keyword and I would bring up all the related scenarios. In terms of who did I interview, these were people from around the world with experience in climate change and related issues, some very, very senior, some from military, some from government, some from civil society. Theory of change analysis, that's how I identified the scenario. So what I did is I was looking for if-then statements. So in the response, if the respondent goes, if this, then that became part of a scenario. And I would take those quotes and plot them out. In terms of the searchable sample of possible futures, it's like having a multiverse of possibilities. I don't know if you know the term multiverse. It comes from physics, and the idea is that we have this moment right now, but then there's an infinite set of possibilities in terms of where the world could go, and maybe all of them happen, maybe only some of them happen. But the idea is that there's a vast array of possible universes going forward. And the approach I've taken is to try and capture that, the multiverse of possibilities, rather than restricting it to 5 or 4 scenarios. In terms of plotting these scenarios, I used theory of change analysis, looking for the if-then statements. And I made a wee graph of each one, with time on the bottom axis going from left to right, and issues from bottom to top. In terms of issues, things that were more local were put further down, and things that were more global were put higher up. Here's an example. So one of my respondents said, if there's some a series of certain catastrophic events, there may be incentive to strengthen the targets, and that'll be success. They'll muddle along, they'll do some will do a lot, some will do not much, etc. And on the other hand, I suppose the scenario I'm offering, my personal view is that there might be some relaxing of the target. So in this case, the person gave multiple possibilities in terms of a response to a catastrophic series of events. So there was a catastrophic event, there was a strengthening targets, there was muddling along, and there might relax targets. When I asked for the scenarios, I was asking for failure or success, and on 7 occasions, people gave me these branching scenarios. And I'm presenting the branching scenarios because they highlight some of the key issues which emerged from the survey, but also because it's a nice quick set to go through rather than going through all 176. Okay, so here's another scenario which has been plotted out. The big green box, by the way, is the current situation according to this person. Okay, sea level change locked in, sea level rise over the next few decades, changes to coastlines. Best case scenario, slow sea level rise and political action, socioeconomic adaptation. Worst case scenario, political stagnation and a rapid sea level rise. And this person then highlighted the influence of climate change is most strong when it affects the wealthy. If climate change is affecting the poor, they said maybe it's not going to have much influence on government and politics, but if it's affecting the wealthy, by gosh, they will get up and they'll make sure things happen. The person also highlighted countries will be vulnerable to political turmoil in some cases, and saying New Zealand's not invulnerable to that either. A food crisis. Food crises came up in several. In this case, this person highlighted the difference between defensive, well, highlighted that it's possible that there could be either a defensive or cooperative response. With regards to defensive responses, in no cases did any of the defensive responses create a good situation. They were short-term, they involved actors looking after their own interests, but undermining the ability of other actors to look after their own interests. So hence, whereas a cooperative response meant that a much better outcome could usually be had. Low greenhouse gas emissions infrastructure investment is needed in this particular scenario. The timing of investment is important, specifically with regards to whether it's before 2030 or after 2030, leading to success and failure. And this is also consistent, I should add, with the IPCC 1.5 degree report, which highlighted the need for these things to happen before 2030. Another scenario, governments should increase research spending. Research came up quite a bit in the scenarios. Need to focus on long-term research. So in this case, the person was saying, well, you know, some of those worst-case scenarios that are being discussed, if we need to solve them, we're going to need things which we don't already have. We're going to need the long-term research and development rather than short-term stuff. So we need to avoid close-to-market research funding. The person also highlighted the solution is not perfection, but partial. So you could argue this is like currently at 1 degree Celsius. We're not going back to 1990 levels of global warming. We're not even going to keep our current levels of global warming. We're going to have something in the future. Other participants highlighted that where we end up, we'll probably lose things along the way. The things that we hold dear may be lost. Coral reefs being a classic example. Here's one where a socially driven scenario where youth take their own path and creates an enlightened response. Now, enlightened, you might be saying, well, that's an interesting word to have in a scenario. It is, and it came up a lot. It came up in business scenarios. It came up in social scenarios. It came up in political scenarios. the Enlightenment theme is one that I was not expecting, and it came up a lot more than I anticipated. And what do we mean by enlightenment? Well, it means awareness that creates change. And in this scenario, the youth become a driving force based on that awareness that creates change. That person also highlight, well, maybe that doesn't happen. Maybe one becomes selfish and people focus on their next expensive vehicle. And this ties into the theme of overconsumption and overproduction. Globalism versus nationalism was a key concern. People were very concerned around the trends, macho politics, increased nationalistic tendencies, particularly in powerful nations. But in some scenarios, it was possible that there would be that climate change goes from being an issue of environment and development to an issue of international security. And hence it gets elevated to the United Nations Security Council, and a coordinated response happens from there. This also gets back to the issue of power. You saw in the previous scenario about wealth being important versus poor people being affected. If the Security Council decides to act, what that really means is that you've got the permanent 5 members deciding that this is something that needs to happen. And other people highlighted in their scenarios that if the permanent 5 agree to something, the other states will participate and comply, not because of sanctions, but because they wouldn't dare risk the sanctions. So hence you have a scenario where there's a concerted response before 2030 or a concerted response after 2030 being too late. Under the other scenarios, a lot of things were collected. You know, there was volcanic eruptions, nuclear war, global recession. There was a pandemic scenario as well. It's a fairly simple scenario, but what the person said is, look, a global pandemic, a bug causing population decline, it demonstrates the value of international cooperation, so it's shown to be useful, and strengthens faith in international cooperation. So it's a really simple scenario that was put forward, but the idea was that, and this gets back to the Enlightenment theme, people see that it's worth working together on an issue, hence that awareness creates change, and they decide that those lessons should also be applied to climate change. There are lots of other scenarios. I'm not going to go through all of them because there's too many. The idea of this was just to give you a sense of the method by which I used, how I plotted out the responses I got from people, and then also to demonstrate that it covered a wide range of things. In terms of the number of steps and layers, so number of steps refers to the number of boxes from left to right through time. So each step is a new period of time, and the maximum number, and then the number of layers refers to going from local to global. So the maximum number of layers in any one scenario was 14. So they had 14 different layers going from very local to very global. And the maximum number of steps in terms of the number of things that happened in a row through time was 7. So these are really simple scenarios. You know, some of them were just a single statement. Others were just 2 layers or 2 steps. But the important thing here is scenarios are restricted to essential details. Why? Because every additional condition reduces the chances of a scenario happening. The more elaborate, the more rich a narrative there is around a scenario, the more things that have to happen. And it's just like playing lotto. You add an extra ball and the chances of winning gets that much smaller. Okay, data analysis. How are we doing for time? Okay. 176 scenarios formed the searchable sample of possible futures. This consisted of 7 branching scenarios, which you've seen, 50 failure scenarios, 67 success scenarios, and 52 other scenarios. All scenarios and scenario elements were accepted as being possible futures. The idea is that even though these things may not necessarily be that plausible, if they are conceivable, then they get counted and included in the set. One of the problems that happened during the financial crisis, for example, when they were stress testing banks beforehand, is that they wanted severe but plausible scenarios. After the financial crisis happened, they realized that none of the stress test scenarios they were applying were severe enough. there was a tension between being severe and plausible. That's why starting with the future and working your way back becomes important. What is failure, and then what are the conditions that lead to that? What is success, and what are the conditions to lead to that? The idea here is not to restrict scenarios, but to include as many as possible. So instead of restricting the study to 4 or 5 reference scenarios, which are very good for communication purposes, the study mapped multiple possible pathways between scenario elements and themes. The analysis focused on conditions found in success scenarios, and common conditions in success scenarios are preconditions for effective responses. The results. Okay, so what we have here is we have climate change, national interest, and international cooperation. That regards the kind of the big system that we're addressing in terms of the scope of the study. There's an underlying model, by the way, for climate change, national interest, and international cooperation, which I won't go into, but if you want to, I can discuss that offline. But in terms of the key themes that emerged, these included physical systems, biological systems, human and managed systems, social change and behavior, political will and policy, technology and practices, business and economic activity, and other factors, international regime, and international cooperation on climate change. So these are your overarching themes. The 2 grey boxes at the top, these regard key concepts that emerged from the qualitative scenarios that were collected. Impact, risks, and signals, and then responses. I won't go through this in complete detail, but what this shows is that for social change and behavior, that little green box in the middle, I mapped out the possible preconditions leading to social change and behavior over here, and then the possible responses that happen thereafter. So you have your impacts and risks affecting information on climate change and risk. You've got your distribution, etc., your technologies and practices, all of which influence these things. You've even got enlightenment. Then you've got public opinion, demanding accountability, consumption choices, etc., which then affect political will and business and economic activity. So what this is this represents, when I go to my sample of possible futures, I type in social change, or I type in behavior. I then get all of the scenarios available, and I map out the possible preconditions, and I map out the possible responses around this theme here. I did the same for political will and policy, institutional processes, new technologies and practices, disasters, catastrophes, lobbying by business, all can have an influence on political will and policy. At the top there is also, excuse me. At the top there is also development capacity. One of the things that was noted is some places have more capacity, some places have less capacity. That has a bearing on what response possibilities you have. And then there's all kinds of response possibilities, including research and development, regulations on land, as well as other things. Business and economic activity, very much driven by social change and behavior and political will and policy. Very rarely was it a leading, it was generally a following in most scenarios. And very much, again, the signals regarding the possible preconditions regarding interests. This was also done for atmospheric greenhouse gas removals, this process of looking up greenhouse gas removals and then seeing all the possible scenarios. And this helps address the question of what are the preconditions for greenhouse gas removals. In terms of technology-based removals, one of the interesting ones is a low price, zero emissions energy. It helps power the greenhouse gas removals technologies while at the same time helping support mitigation. Mitigation was seen as essential, by the way. If you don't mitigate, you have to take out too much greenhouse gas emissions. If you mitigate, it makes it easy to take out emissions. Plus also, no one's going to remove greenhouse gases if someone down the road is emitting lots. So in terms of a game theoretical perspective, it makes sense also. And then, of course, with regards to land-based emissions, policies being very important and practices. Okay, international cooperation on climate change. Again, a whole lot of things here. It really comes down to, in terms of scenarios, coalitions of powerful interests versus coalitions of weak interests and states. And then there's a whole range of options. In terms of the effectiveness of international cooperation in climate change, it depended on participation, compliance, stringency, flexibility, and ambition. And this is drawn from the literature, not from the scenarios per se, but the rest of it is drawn from the scenarios. Okay, so I know that's a lot, and I've included them so we can go back to them if we need to during the discussion. But the thing which I really want to get to, which helps answer this question of what are the preconditions for an effective global response, regards the impact and risk signals and the responses. This is the conceptual part of the study. So if we take the global response to climate change as a system there, the big bar down the bottom, we have impacts and risk signals and responses. So those impact and risks, climate change signal in my parlance, and then there's the response. That's level 2. Level 3, climate change signal can be broken down into climate stress as well as actor interests. And then you've got your actor decision making, the actions they take, and the contributions to the global response of those things. Level 4, things get a bit more complicated and a bit more detailed. So in terms of climate stress, we have climate science, we have hazards to human and managed systems. Human systems, you know, the businesses, the world we live in terms of those things. Managed systems, agriculture is a great example of that. You could have highly managed agricultural systems, greenhouses. You can have less managed systems, and you can have very lowly managed systems, you know, dry land sheep farming in the hills, for example. A lot of natural processes there, but it's also managed to a certain extent. So human and managed systems, there's hazards there, and there's hazards to natural systems. These make up your climate stresses, which contribute to a climate change signal. Okay, so which of these do you think was most likely to generate an effective global response to climate change? Well, it was hazards to human and managed systems. From the sample of possible futures, only impacts and risks to human and managed systems generated effective global responses. I interviewed people who were concerned about the environment, they were concerned about business, they were concerned about politics, they were concerned about government and policy. Even the people that were deeply concerned about the environment and were very much against technology solutions, in no cases gave a global response that was effective that responded to natural systems. It responded to human and managed systems, to the hazards to those things. In terms of the terminology, where did I get this terminology? Well, it's from the IPCC. The IPCC talks about climate science, it talks about human and natural systems, it talks about human and managed systems, it talks about natural systems. The Task Force on Climate-Related Financial Disclosures, which was set up by Mark Carney in his head of the Financial Stability Board capacity, and he got one Mr. Michael Bloomberg to come up with these recommendations on different types of financial disclosures, and these included physical risks. So hazards to human and managed systems are what the TCFD would call physical risks. There's also transition risks, according to the TCFD. And these are the response options and the extent to which these response options are a risk or an opportunity. And that very much depends on the actor and their interests. The important thing about these transition risks, these response opportunities and risks, is they can enhance or suppress ambition. You can go from being very high ambition to very low ambition, even negative ambition. So if, let's say you ignore climate change, but you've got special interests around oil and gas, you may have negative ambition. Let's say you don't care about climate change, but you happen to be involved in solar energy, you may have very high ambition. The response opportunities and risks moderate, they can enhance, they can suppress ambition. Well, what are the triggers and drivers that were identified from the scenarios? A cynical response was identified as being one possibility, a fossil fuel push. A non-response, that could include apathy, it could include hopelessness, the scale of the problem's too big. It could involve hypocrisy, saying, well, I understand it's a problem, but you know what? Yeah. Other triggers and drivers, a cost-benefit response, an enlightened response where awareness creates change, or an emergency response where, guess what, this is a real problem, we have to do something right now. Then there are a whole range of attitudes that come with this. You could have an emergency response that is defensive, or you could have an emergency response that is cooperative. Then you have your options which you consider. You have your actions, and then the extent to which these actions make positive or negative contributions to the global response. So that's roughly where we left off. So what about the climate change stress signal? So we go back to this wee mental model, which I presented earlier. Well, if we take the second assessment report in its summary, it said unambiguous detection of climate-induced changes in most ecological and social systems will prove extremely difficult in the coming decades. So remember, impacts on human systems is really the key thing when it comes to a signal for driving a response. And here we're saying it's going to be decades away. Essentially, there was no signal back when during the Rio Convention. Okay, now let's take 2014, the IPCC assessment report. This is from the summary for policymakers. Some impacts on human systems have also been attributed to climate change, with a major or minor contribution of climate change distinguishable from other influences. This essentially means that the climate change signal was only just emerging the year before the Paris Agreement. That's the climate change signal that really matters. We had climate science, yes. We had impacts on natural systems, yes. But in terms of attribute impacts on human and managed systems, they were only really starting to turn up in the last decade. Okay, so then we have the 1.5 degree report, and it highlights that risks of impacts to human and managed systems are undetectable to moderate at 1 degree Celsius. This is not a quote. This is taken from those reasons for concern, those graphs showing white at the bottom through to purple at the top, and the extent to which these reasons for concern are there's the risk of impact. At 1.5 degrees Celsius, the risk of impacts to human and managed systems is moderate to high. So we're going from undetectable to moderate, where we are now, to moderate to high. And by the way, when is this expected? When are we likely to reach 1.5 degrees C? Sometime between 2030 and 2052, according to the 1.5 degree report. When we get to 2 degrees Celsius, the risks of impacts on human and managed systems are moderate to very high. So this analysis where I looked at the signal and started going, well, hang on, what is the signal? What's the real signal here that really matters? And if you're a politician, the one that really matters is the current impacts. Risks are sometime in the future, especially when we talk about 2100, that's way in the future. Nature versus people, well, impacts on human and managed systems. And then when I went through, I realized, guess what? The signal was only just emerging, but the next point, it's going to change real quick. We've gone from it being undetectable to moderate, and we're suddenly going to be at moderate to high, and then moderate to very high in short order, geologically speaking, over the next 20 years. So what we're seeing is a fundamental shift in the global response regime. So the climate change signal has only just emerged, but is likely to get stronger soon. What does that mean in terms of our response? Well, guess what? It's complicated. It all depends on our ambition levels, what we take out of it. Cynical responses involving special interests, deliberately negative contributions, the burn baby burn type mentality. Then there's a non-response. Then there's the cost-benefit responses. What's the problem with a cost-benefit response? Well, if we take all the things we need to do, and then we do a cost-benefit analysis of all of them, we only do the ones that make economic sense. All the others we leave out. When we get to high to very high, an enlightened response is important. Why is enlightened important? Because enlightened can be influenced not just by climate change and the signal we're getting from climate change, but also from other lessons learned. Going back to the pandemic response, an enlightened response, the awareness that creates change. The awareness could be around, hey, collective action is really important. Why don't we then apply the lessons from the pandemic to climate change? And we're seeing that narrative emerge, obviously, now. But that's what enlightened responses brings in. The ambition level is not driven exclusively by climate change, but it's also driven by other wider societal lessons. A security response. Okay, climate change is a clear and present danger. It's been decided it needs to be acted on. And it's now a question of how do we solve this with the resources available. It's no longer a cost-benefit analysis, it's a cost-effectiveness analysis. And we can either do containment and defense, which doesn't lead to very good scenarios in terms of the globally, or containment and fix, where we say, not only are we going to contain this, we're going to fix it. Fixing, of course, involving greenhouse gas removals in most scenarios. Okay, so there's a range of possible responses. It's not clear that we necessarily get any one of these. One of the problems with a security response driven by impacts is that the hazards creating those impacts are probably part of the new range of normal conditions. If we respond to risks, then maybe we can get ahead of it a bit. But the problem with risk responses is you need a really clear and unambiguous signal, and trying to get that, that's kind of hard. So mapping out all the possibilities in terms of climate stress, risks, opportunities and threats, the ambition levels, the types of responses, the attitudes, the options considered, and then the contributions, well, it's complicated. So fortunately, I'm not going to go through this chart for you. I'm going to go to the simplified table, which is also a little complicated. The table focuses on contributions to the global response, that last part on the right there. There are more likely to be positive, likely to be negative overall, or likely to be very negative contributions to the global response. So which responses generate these things? An enlightened or emergency response with cooperative, competitive, or technological attitudes is more likely to be positive. A cost-benefit response with cooperative, competitive, or technological attitudes is likely to be negative overall, still have more emissions, less resilience. A cost-benefit or emergency response that is defensive is likely to be very negative in terms of its contributions to the global response. And a no-trigger, non-response or cynical response, again, given the current technologies and practices, very likely to be negative. So hey, we're nearly there. We've nearly got the preconditions for an effective response, except we don't. Oh, hang on. I jumped the gun. That line was meant to be after the next slide. Damn. Okay. So now this table, it takes the same information before, but it looks at the effectiveness of the global response. So the previous table looked at the contributions, and this table looks at the effectiveness of the global response. The big difference is power and capacity. The power to influence other actors, institutions, and the rules of the game. And the capacity to develop and implement technologies and practices. If you have power and capacity and take an enlightened response with cooperative, competitive, or technological attitudes, then it's much more likely to be effective. If you have the power and capacity and take a cost-benefit type response, then it's unlikely to be effective. And if you have the power and capacity and take a cost-benefit or emergency response, cost-benefit or emergency defensive response, it's very unlikely to be effective. Or if you do no response, then it's very unlikely to be effective. Why? Because you count for a lot more than other actors. And when I talk about the power and capacity, I'm talking about the coalitions in particular here. So if we have the permanent, going back to, let's say, the Security Council type scenario, why is that important? Because it highlights the need for those permanent 5 members. They have power, they have capacity. What they do has a much bigger bearing on the effectiveness of the global response than what Tuvalu or New Zealand does. So those with limited power and capacity, it doesn't really matter. It matters much less what happens in terms of the immediate effectiveness of the response. So now it looks like we're getting pretty close to the preconditions for effective global responses, yeah? Except there's a real complicating factor. I'm not going to go through all of this, but the point is that global warming has many different factors, including climate forces, the things that help keep that create global warming, yeah? And when you look at those climate forces, the radiative forcing, there's big uncertainties, yeah, in terms of the anthropogenic radiative forcing. Why is that a problem? Why is that a problem when it comes to looking what does it take for an effective global response? Well, you'll recall the effective global response is defined using the UNFCCC objective, stabilizing greenhouse gases at levels that allow ecosystems to adapt naturally, food production not to be threatened, and economic development to proceed in a sustainable manner. The extent to which climate changes for any given concentration of greenhouse gases, there's a certain level of uncertainty there. So what that means is it's conceivable that global warming might be less than expected, but unlikely, and very unlikely in many cases. So the problem I had was, okay, well, now I've got this information. I've got this information around contributions to climate change. I've got this information around the effectiveness of possible responses and the role power and capacity has. But I've also got this problem around, there's still some fundamental uncertainties around the science, and it's still conceivable, even if unlikely, that a higher concentration will still leave us with lower levels of global warming than anticipated. How do I honestly put all of this together in a way that is logical and makes sense? So this is my attempt. I had a nice graph, but it's kind of hard to explain. So what I'm doing is I'm just doing this simplified table. So effective response scenarios, and these are similar to what you saw before, but then you'll see there's a new category, serendipity. Turns out serendipity is really important for an effective global response scenario. I'll go back to leadership last. But let's start with enlightened or emergency triggers, and then cooperative, competitive, or technological attitudes. So you have an enlightened or emergency response with cooperative, technological, or competitive attitude. That requires high levels of serendipity. This includes climate sensitivity no higher than anticipated. Climate change and related impacts can be halted, you know. The idea, we're not even sure that it can, but let's hope we can. Huh? Greenhouse gas removals can be done at a scale if needed. Other unexpected changes don't hinder the global response to climate change. This is the serendipity we need if we have, let's say, an emergency or enlightened response. What about a cost-benefit response with cooperative, competitive, or technological attitudes? Well, we need very high levels of serendipity. This includes climate sensitivity lower than anticipated. Climate change and related impacts are reversible. Are they? We don't know just yet. We've seen in the geological record it can go up and down, but we've never actually been there to see exactly how it happened. Climate resilient low emissions technologies and practices become cheap quicker than expected. You know, if we're going to have a cost benefit to decide everything, then we're going to have to hope that electrification of transport happens quicker than we expect, that renewable energy gets cheaper than we expect, and storage gets a lot cheaper than we expect. Greenhouse gas removals technologies and practices are available and can be done at scale. Again, we have to hope that that's there, because if we wait till it's cost benefit positive, then it may be in a rather difficult regime. Other unexpected changes help the global response to climate change. We have to hope that whatever else happens in the world, economically, environmentally, socially, it doesn't make things worse for us. Okay, and then we have incredible levels of serendipity regarding defensive responses and failed cynical responses, etc. So the preconditions for an effective global response: scale of climate change is limited. Climate change and related impacts are reversible and can be quickly stabilized. The global response is timely in its scale, including adaptation, mitigation, and atmospheric greenhouse gas removals. Contingencies are available for addressing extreme climate change or other scenarios. Other changes don't negatively influence climate or the global response to climate change at scale. These are the things any strategy should really take into account. The scale of climate change can be addressed using available technologies and practices. That's what it means by the scale is limited. Atmospheric accumulation of greenhouse gases are limited. That will also help ensure the scale is low. But that accumulation is not just our own greenhouse gas emissions, but also relies on nature-based stores of carbon. Climate sensitivity is lower than expected or not much higher than expected. That will keep the scale down for us. Not passing thresholds or tipping points, that will help ensure climate change-related impacts are reversible and can be quickly stabilized. In terms of the global response's timing at scale, leadership generating response opportunities. Leadership, social, political, business can create those opportunities, can create technologies, can create policies, can create practices which can be applied at scale when we need them. Social permissions for climate action. This came up in many scenarios. One person highlighted, nowhere in the world do we have a social contract that would allow us to do what we need to do to solve climate change. Domestic and international coalitions with capacity and power to ensure timely responses at scale. We need domestic coalitions. We also need international coalitions. Domestic coalitions shape what we're allowed to do in terms of international cooperation as well, but they also shape our own emissions profile and resilience. Research and development of technologies and practices and policies so they can be deployed quickly and at scale if needed. This helps with contingencies, and contingencies helps with resilience. The scale of other changes can be addressed by technologies, practices, and institutions and policies. So all these other things that might happen, social crises, economic crises, environmental changes, we need technologies that might be addressed, we need practices, but we also need institutions, the arrangements in society to be durable, to be resilient, and we also need the possible policies to address them. And I think COVID has highlighted this in terms of New Zealand versus, let's say, Sweden versus, let's say, the US. Other changes limit climate change or help the global response. We have to hope that whatever these other things that happen, they don't make it harder for us. The conditions under which actors would act, this is the last slide in terms of these things. Conditions versus problems. Conditions society can live with, problems society believe need to be solved. The reality is that there's the climate change signal, but the extent to which people believe it is one thing, the extent to which people believe it should be solved is another, and then whereabouts on the policy agenda? Is it number 1 or is it number 10 or is it number 100? And then the coalitions, how do we bring together coalitions, not just of climate change concerned, but also other people interested in the same options to make this happen. So in summary, from the sample of possible futures, only impacts and risks to human and managed systems, including agriculture, for example, we're capable of driving effective global responses to climate change. The climate stress signal in the form of impacts to human and managed systems has only recently emerged. This represents a fundamental shift in the response system. How this will influence the global response is unclear. Serendipity is an important part of an effective global response to climate change. Leadership can create the conditions for serendipity, creating options for the global response in the future. The global response depends on the extent to which climate change is a problem that needs to be solved versus a condition society lives with. It also depends on how the climate change problem is defined. Will we define climate change as stabilizing greenhouse gas emissions at levels that allow ecosystems to adapt naturally? Or will we redefine the climate change problem as one of limiting vulnerability and exposure to climate hazards so we can have food production and continued economic development? So questions, I'm just going to pose a few questions to start. Who are the main actors in New Zealand? What signals are these actors getting? Which scenarios are we considering? And to what extent are we relying on serendipity? Thank you very much for staying with me, and I really appreciate it. Cheers.
Fantastic. Jeremy, thank you so much for your presentation. I mean, obviously you've shown an extraordinary level of courage in tackling this topic and trying to come up with a comprehensive framework for thinking about these drivers, and you've really shown the complexity of the layers that could go into outcomes. This is a huge amount of material to try to digest in a very short period of time. A tribute to your work, but also a challenge for us as participants. In terms of the next steps, I've invited Jonathan Boston and Christina Hood to give some short response for just a few minutes each, and then I'll open it up for Q&A. I know that we are running a little bit late, so the comments from Jonathan and Christina may take us to the hour. I'm certainly available to stay on until 12:30, and Jeremy, are you able to stay on as well?
Absolutely, thank you.
Yeah, fantastic. Okay, in which case the recording is still going, and Jonathan, I will turn it over to you. Take it away.
Okay. Thank you very much, Catherine, and thank you, Jeremy. It was a fascinating presentation. You've done some remarkable research, and you have some important findings, a wealth of material, obviously very complex. If I interpret your findings correctly, then the implications for humanity are deeply concerning. You basically, I think, present a case that the conditions for effectively responding to climate change cannot be met, or at least are very, very unlikely to be met. So you've probably just intensified my largely black hat orientation on climate change. Let me just briefly comment on 4 matters. First of all, your research question, your main research question. Secondly, your research methods. Thirdly, what might be missing from your analysis. And fourthly, what are some of the key lessons for climate change policy from the current pandemic? And I'll be very brief, Jeremy. There's an awful lot that could be said, and I don't want these comments in any way to take away from the enormous breadth and richness of your analysis. But starting with the research question, you start with the question, what are the preconditions for effective global responses to climate change? And when I saw your presentation last night, I have to say, I thought it was a very open-ended question, if not somewhat vague. It was unclear to me initially whether you were talking about mitigation or adaptation or both. It was a little bit unclear what was meant by effective. And the 4 conditions you mentioned from the IPCC, sorry, the UNFCCC are also, rather vague. You don't like a temperature target, but that is in fact somewhat more specific. And then it was unclear to me what was meant by global responses. Are we talking about international organizational responses, national responses, subnational responses, business, or all that? And then you do reframe your questions and tighten them somewhat. And I appreciate you doing that. One of the sub-questions is, what are the conditions for international cooperation? But I'm not sure that you really fully address that specific question. And I wonder if there might be a more precise and perhaps a more important and helpful question. And if there is, one possibility would be as follows. What are the necessary conditions for rapid decarbonization of the global economy, and especially global energy and transport systems, in order to have a reasonable chance of avoiding some particular temperature increase, be it 1.5 or 2 degrees? And that would focus us very specifically on decarbonization, and particularly decarbonization of the energy and transport systems. It might also lead on to thinking about negative emission technologies, removals, etc., and so on. That might be a subsidiary question. So I do have some reservations about your research question or questions, and whether you've perhaps tackled those as adequately as you might. Secondly, your methods. So as someone like me who's written a bit about foresight, I'm very open to the use of foresight methodologies, such as scenario analysis, backcasting, and so forth. Likewise, I think focusing on theories of change, the if-then statements, thinking about intervention logics, and so on, all that I applaud. And I think this is a totally respectable way of trying to address some really challenging issues and questions. I think your use of expert interviews in the way you have is thoroughly commendable, and it generates some really interesting findings. But there are, of course, other plausible methods for investigating the sorts of questions that you're interested in. And one possibility, and this is just one, would be to explore empirically where greenhouse gas emissions have been reduced most significantly over recent decades, whether at the national level, the subnational level, for example, in the United States, or sectorally, and then ask the question, how have these reductions been achieved? Why is it that some countries and some states are doing better than others? What are the drivers of these differential results? And then one could explore, in many ways, things you have already done, but you would explore them from a slightly different perspective. What are the respective contributions of the different elements that might contribute to these differential decarbonization outcomes? What role, for example, do policy frameworks and measures play? What role, for example, does technology innovation and the uptake of that innovation play? What role does investment in low emission technologies play? And what is the potential role for investment in sequestration and so forth? Now, if you approached it in that way, obviously there's a range of possible answers. From my reading of the evidence, and there'll be other people participating in this event that will have possibly different views, but it seems to me that an absolutely critical factor in reducing greenhouse gas emissions currently is shifting investment flows, particularly private investment flows, towards low emission technologies and away from high carbon technologies. And then the question becomes, well, what are the necessary conditions for shifting investment flows? And that would then take us to a careful analysis of the respective roles of policy frameworks, of innovation, relative prices of different energy sources, and so on and so forth. Third quick comment, what's missing from your analysis?
Yes.
Well, as someone who's primarily trained in political science, I did think you were a little bit light on power and politics and political economy, at the national and the international level. I would probably urge you to do a little bit more thinking about that. Maybe it's in the detail of your thesis. If so, all well and good. But I do think the politics of this probably matters quite a lot, at least in shaping the context in which investment occurs. Final comment is really about, well, what are the lessons from the current pandemic for tackling climate change? And let me just mention two. There are many possible lessons, but here are two. First of all, it seems to me that global cooperation is highly desirable in order to meet a global challenge. But it seems that that cooperation can be readily thwarted by major powers, particularly the United States and China. And so that highlights the critical role of power in the international arena and of the leadership of specific nations. Second key lesson, in my view, from the current pandemic is that extraordinary policy responses are possible when there is sufficient political will. But getting that sufficient political will requires, it seems to me, an immediate and serious threat of large-scale harm, particularly a large-scale loss of life. And that is probably a little bit consistent with your view that only hazards to human and managed systems, and probably very serious hazards, will generate effective responses. If that lesson is valid, then sadly, there is little hope of getting a similar response to climate change that we've had to the current pandemic. And on that rather sobering note, I'll pass over to Christina.
Was just going to reflect on the New Zealand question rather than the kind of research frameworks and the questions and the methodologies, which Jonathan is far more of an expert than me about. And just sort of some personal reflections on what some of the elements of the presentation prompted in my mind. I think, you know, it was interesting to me thinking around, you know, the potential ranges of these preconditions that we have moved on a lot in New Zealand over the last 10 years or so. You know, when you think back to the policy debates that many of us were involved in back then, it was all about the cost benefit and should you do it or should you not do it, and how much will it cost? And the front page of the paper was, oh my God, the price of petrol is going to go up by 6 cents a litre. We have moved to, I wouldn't say an enlightened position, and you know, the framing of this presentation, maybe fragilely enlightened. There's a general kind of public consensus that we need to do this, but it seems pretty fragile. And that's one of the things that, and for me, was a reflection from listening to the presentation. We don't really have quite the set of conditions that we need to actually be able to respond to the problem as science tells it to us. So we're needing to move ahead, if you like, of the signals and maintain that very fragile consensus that we sort of have, rather than pulling away from it. So, and you know, as Jonathan was alluding to, the COVID-19 situation exacerbates a lot of this. So we have this social demand for action on climate change, but I think that's going to be very fragile when people are wondering, you know, where money is going to come from to put dinner on the table.
Mm-hmm.
Have a political census from the Zero Carbon Act, but that's so far untested. You know, the Climate Commission, you guys need to put up your first set of budgets and see if we can maintain cross-party political consensus through that. Business investment needs trust that that process is going to continue and be walked back. And all of this depends on what other countries are doing, because we are so interconnected economically, but also the kind of the momentum of climate action internationally is what we need. You know, the obvious thing that we don't solve this problem on our own in a mitigation sense. We need other countries to be acting for our own interests. And I agree with Jonathan completely that there's, you know, big risks around from the COVID response around how the international community deals with that. I certainly personally feel like, you know, I've learned this lesson that in the is going to look out for my interests in the end. You know, you see this with countries repatriating their citizens and so on. So yeah, really big emphasis coming up around resilience, supply chains, and what do our national interests look like and so on. And I can't even begin to kind of frame what that's going to mean for the climate debate, but it is something that I think adds to the fragility of this perhaps consensus that we have around the need to act. So at a domestic level, one of the things that this tells me is that as we proceed in trying to put together policies to get us on track for emission reductions, they are going to have to be really, really much smarter than they have been in the past, looking at individual actors, where the costs and benefits and the incentives fall, and actually addressing those at the level of every single policy, not just making these sweeping statements of, oh, well, you know, a carbon price is best for the economy overall in terms of, you know, cost benefit or even cost effectiveness, without thinking about, you know, who's going to get left behind, how that affects the social and political buy-in to the change. So really looking at that political economy issue is going to be even more important. And again, just with a parallel to the COVID-19, it's something that's really struck me around some of these positions of economy versus health benefits. It's like, well, you know, it might be best for the economy overall if we took a hit on, you know, some people's health or lives somewhere else. And it's this sort of really kind of tin-eared response that is not what people want. And I think we're going to have to, as we think about climate policy, be thinking in that way as well, thinking about, okay, well, what does this mean for every individual, every sector, and so that we can try and keep that fragile consensus that we have.
Thank you very much, Christina. And let me see, I think from this point, what I'd like to do is give Jeremy a chance to respond to those comments. And for those of you who would like to ask a question, if you can use the chat window and just do a chat to everyone, just say, I want to ask a question. I know a couple of you have posted some interesting questions as we've gone. But what I'll do is just start making a hands up list while Jeremy is responding. And Jeremy, I'll turn it back over to you.
Yeah. Okay. No, thank you very much for that feedback. And one, thank you, audience and everyone, because this, you're really the first group I've ever tested this on. These things have only come together recently, and they formed in isolation, I should add. So with regards to the question and the methods, when I started out, I was very much focused on, you know, the possible scenarios and then looking at what are the options and who might do them. But the problem with trying to organize a study around that was every time I put forward various options and started with that as a starting point, I was already limiting the multiverse of possibilities. I was already limiting the extent to which the study could really address the entirety of the issue. And the reason why I felt addressing the entirety of the issue was so important, and it goes against what we should do in a PhD, yeah? I mean, in a PhD, we should get to a focus really tight and deal with that, eh? In this case, I've done exactly the opposite. I've gone to the very top of the pyramid and said, what is the most big thing I can deal with here? But why is that important? Because people have to make decisions on this. There are world leaders, there are business leaders, there are social leaders, there are individuals, each making decisions that have a bearing on this. And for people that have to make a decision, they have to have some kind of frame. And it's a difficult issue. There are so many aspects to it. How do we bring it together? So the metaphor I use, and I'll wrap up in 2 minutes, but the metaphor is simply, you've heard about the blind people and the elephant, yeah? They hear about this elephant, they want to know what it is. They go up to the elephant, they each feel a different part. One feels the leg and says, hey, it's like a tree. Another feels a tail, says, hey, it's a bit like a rope. Another feels a trunk, says it's like a snake. Another feels a side and says it's like a rock. And these blind people get in a huge argument around what is an elephant. And someone who is sighted comes along and goes, what are you guys arguing about? And they say, well, you know, there's this tree, there's this trunk, it's an elephant, but this other person's clearly got it wrong, or they didn't appreciate the issue. And the person that could step back and look at the entirety of the elephant, they're able to say, well, you know, that snake you can feel, that's the trunk, but that's also joined to the head. And that fan you can feel, that's an ear on the side of the head. And that rock, that's its belly. And its legs are so big, it feels like tree trunks. They're able to explain the entire system. And people going into making decisions on climate change, I figure, probably need some kind of frame to understand that wider. They need to understand the elephant and where each part fits. Each academic discipline is a bit like a blind person feeling a different part. And we've been going into the detail a lot. So I wanted to step back and say, what is this big system? How does it come together? And when I tried doing it by focusing on specific technologies or options, I found it too limiting. And eventually I stepped back and said, let's just keep it entirely open. And let's focus on the UNFCCC for the definition of success, because it's internationally mandated. If I chose anything else, I'd have to defend it much more because that's my own choice. This one was agreed. The Paris Agreement has one goal and a whole set of conditions for achieving that goal, or a whole set of actions. So it's much more action oriented. It's about implementation. So that kind of covers the question and the methods part. So I very much I didn't want to shape people's views. I kept it as open as possible and then brought in the multiverse. The key lessons, and so in the COVID lessons, one thing that's, I think, important is the frame that comes out of this can also be applied to COVID, the signal response model. What is it about COVID that's generating a signal? What is it about actors and their interests that can enhance or suppress that signal? What kind of attitudes are they bringing to it? Are they bringing a cynical, or are they bringing an emergency response, or are they bringing a non-response? It provides a frame for starting to deal with some of these things. In many ways, there's a lot of parallels there. In terms of climate change, yes, it highlights a lot of lessons. And one of the ones, just finishing here in terms of it highlighting, is what happens when we have a defensive response versus a cooperative response. Clearly, I don't know if you saw the World Food Programme yesterday saying we're doubling the number of people in severe shortage of food and starvation. I mean, it's a tragedy.
Jeremy, you've just held 2 hours of fascinating conversation and knowledge sharing. Thank you again for sharing your research with us. We'll look forward to following the conclusion of your research and your process as you move toward publication. And yeah, hope that you'll be available to collaborate with New Zealanders as we try to shape scenarios and pathways for our own way forward. I'll just close with maybe 3 personal reflections as I've been listening to you in the discussion. I had a little bit of the same reaction as Jonathan when I heard, well, this is a survey of 27 people. You know, how do we validate what comes from them? And I think there is value in looking back historically and trying to identify, well, have we seen validation of this in past results? But we're also facing the possibility of a future that's radically different from the past. And I don't know how much we can rely on the past to predict the future. So to me, there's value in both sets of perspectives, and in trying to harness collective wisdom that comes from the head, the heart, and the gut, and trying to integrate all of that. And your scenarios get to those complex dimensions that don't always come out. And that was my first point. The second is, you said, well, the signal of risk has only recently emerged, you know, suggesting maybe 2014. Well, actually, I think the signal of the risk has been around for a long time. The problem is the validation of that signal. And we're now getting more clear validation. If we wait for more severe validation, it's too late. And I mean, we're perhaps slightly past that point. So I'm hoping your conclusions are overly pessimistic about how much we have to wait to fully validate the signal before we're willing to take action. And maybe that's an area where we can learn from COVID. And I think you just highlighted the complexity of system change. And this is something that I've wrestled with in my own research about individual behavior change, social change. And you've raised 3 issues I'm going to go back and think about in particular. One is how you create coalitions with power. The second is how you secure a social contract for the kinds of change that we're talking about. And the third is this role of serendipity and how we enable maximum serendipity, but also the risks of relying on serendipity, which I think we're probably doing a little bit too much right now. So on that note, I will wish everyone a good afternoon. We'll try to get this information up on Motu's website as soon as we can. And again, Jeremy, thank you for sharing your research with us. And thanks to everyone who's taken the time to join us today. Take good care.
Thank you very much.